Once upon a time, our ancestors were furry creatures, much like our primate relatives. But over millions of years, humans underwent a remarkable transformation, shedding their fur and becoming the relatively hairless beings we are today. Why did this happen? Was it a simple adaptation to the environment, or is there something more profound at play? Join us as we explore the fascinating story of how humans lost their fur. In many ways, hair is one of those fascinating features that humans share with many other mammals, but it's also somehow one of the things that makes us uniquely human. From an evolutionary perspective, hair started out as a way for early humans to regulate body temperature, protect against the sun, and even act as a sensory tool. For example, the fine hair on our skin helps us feel slight changes in the environment, like a breeze or the approach of a predator, and things like that. The core of it is, over time, human hair has evolved in response to the climates we lived in. In colder regions, we developed thicker, denser hair to help keep us warm, while those in warmer climates grew less hair to avoid overheating. But somehow, despite these biological functions, hair has taken on a deeper significance beyond just survival. In fact, it's a key part of how we express ourselves in modern society. From the way we style it to how we color it, hair can communicate everything from personality and cultural identity to social status and even rebellion. In today's world, hair is more than just something that grows on our heads. It's a tool for self-expression. People use their hair to make a statement, whether it's a bold new haircut, a symbolic hair color, or even embracing the natural texture of their hair. At the same time, hair loss or changes in texture can affect how we perceive ourselves, with many turning to treatments or styles to maintain a youthful or trendy appearance. So from what hair has become in our society today, it's intriguing to realize that at some point we were covered completely in thick fur. So what happened? To understand how, when, and why we lost our fur, we first have to look at how we grew hair in the first place. Okay, so hair growth is a complex process influenced by a combination of genetics, hormones, and environmental factors. But we'll try to break it down to its simplest form. At its core, hair grows in cycles and follows a specific pattern set by your genes, which dictates the thickness, texture, and growth rate of your hair. In general, hair grows from hair follicles, which are the tiny structures embedded in the skin. Each follicle produces a hair strand. And this process is fueled by cells in the follicle dividing rapidly and pushing older cells up through the skin. Your hair is made of keratin, a tough protein that gives it strength, and its growth happens in stages. These phases are called the anagen, aka the growth phase, the catagen, aka the transition phase, and the telogen, aka the resting phase. Now let's shift gears to something a bit more important, the length of your hair. See, the length of the anagen phase varies from person to person. For some, it may last only a couple of years, resulting in shorter hair, while for others, it can last much longer, allowing hair to grow longer. For this, genetics play a huge role, as your parents' hair growth patterns will often determine how long and thick your hair can get. Besides this, hormones are also a big factor. During puberty, for example, the surge in testosterone in both men and women causes hair on the scalp, face, and body to become thicker and more noticeable. Changes in hormone levels, such as during pregnancy or menopause, can also affect hair growth, while stress, diet, and health conditions also manage to impact the growth cycle, causing hair to thin or even fall out. In terms of why hair grows the way it does, like on your scalp or face, it's part of our evolutionary history. And it's here that things get really interesting. See, hair does a lot to choose how you look. For one, hair on the scalp helps regulate temperature and protect the skin, while facial hair in men, for instance, may have evolved to signal maturity or status. On the other end of the spectrum, body hair likely served to protect our ancestors' skin from environmental factors like UV rays, insects, and friction. But here's the thing. Why did we lose our fur if it provided so much protection? I mean, wouldn't hair have helped during the multiple ice ages that our ancestors had to endure? Let's start with when we lost our hair, because why is a very long story, and we'll get to that later. The loss of fur in humans was a gradual process that unfolded over hundreds of thousands of years, shaped by a combination of environmental, evolutionary, and genetic factors. Now, while pinpointing the exact moment is difficult, scientists have pieced together a general timeline based on fossil evidence, genetic data, and the environmental conditions of early human ancestors. So, let's dive in. Before 2 million years ago, early human relatives like Australopithecus likely had a significant amount of fur, much like modern primates. These hominins lived in warm climates and, lacking the ability to control fire, would have relied on their fur for insulation, particularly during colder nights. The presence of fur would have been crucial for the thermoregulation, helping to retain body heat in the absence of external heat sources. This period was basically a time when our ancestors were still highly reliant on their fur for survival. But then, an unexpected shift likely began around 1.7 million years ago with the appearance of Homo erectus, an ancestor more adapted to life on the open savanna. Evidence suggests that these early humans, who were the first to leave the trees and spend much of their time on the ground, were evolving for more efficient thermoregulation. The transition from a fur-covered body to a more naked one likely helped Homo erectus cope with the intense heat of the savanna. And with the development of better sweat glands, humans became more reliant on sweating to cool their bodies, and fur loss may have been a crucial adaptation for this method of heat dissipation. By around 1.2 million years ago, there was genetic evidence of the MC1R gene variant in human populations, a gene linked to skin pigmentation. This gene would have been associated with dark skin pigmentation, which is a protective response to the harmful UV radiation from the sun. The presence of this genetic variant, however, suggests that by this time, humans were losing much of their body fur. And as fur became sparse or entirely lost, the skin needed to evolve mechanisms for protection against the sun, particularly in areas where humans were exposed to more direct sunlight due to their savanna-dwelling lifestyle. But that wasn't all, because the presence of the MC1R gene variant also hinted at a key evolutionary shift. Because with the loss of fur, early humans were no longer relying on hair for UV protection, and instead developed darker skin as a defense mechanism against the sun. Essentially, the timeline suggests that the significant reduction of fur coverage occurred during the era of Homo erectus, roughly between 1.7 and 1.2 million years ago. This period marked a critical turning point in human evolution, where our ancestors transitioned to a more naked form. But this wasn't the full story. See, this is when things got complicated, because a lot of theories have come up to ask why we chose to lose our hair in favor of sweat and other heat dissipation mechanisms. For many scientists, the thermoregulation hypothesis explains why humans lost their fur, as they believed we focused on the need to adapt to hot environments and develop better ways to cool down. Essentially, it was all about keeping the body from overheating, which became increasingly important as early humans spent more time under the hot African sun. As we mentioned before, around 4 million years ago, our Australopithecus ancestors started moving out of cooler, shaded forests and into the open, sunny savannas of East Africa. With this move came the challenge of how we stay cool. Now, the key to understanding why this is a problem is, weirdly enough, bipedalism. That's right, the ability to walk upright on two legs. See, while walking on two legs has many advantages, like freeing the hands for tool use, it also exposes more of the body to the sun, increasing the risk of overheating. A problem that would be worse when we fast forward to 2 million years ago, when the Homo erectus emerged. What made them different, though, was their bodies featured a body structure ideal for long-distance running. Essentially, they were tall, long-limbed, and had a bowl-shaped pelvis. These adaptations might seem random, but they were crucial for a unique human hunting strategy called persistence hunting. This strategy was basically early humans just chasing prey for hours until it collapsed from exhaustion. While this sounds like a great or a terrible strategy depending on how you see it, running in the heat for long periods could cause a lot of body heat to build up, and a thick fur coat would have trapped this heat, making it difficult to keep cool. Here's where the reduced fur comes into play, because as early humans evolved to have less fur, they could sweat more efficiently, which helped cool the body down when running long distances. This ability to sweat allowed humans to hunt for hours, sometimes over 5 hours, without needing to stop for water because the sweat was cooling them down as they ran. Now, the connection between sweating and fur loss is crucial here, because as we lost our fur, we developed eccrine sweat glands, which produce watery sweat that evaporates and takes heat away from the body. Unlike apocrine sweat glands, which are used mainly for scent, eccrine sweat glands are great for cooling because they help regulate body temperature. Today, humans have between 2 and 5 million eccrine sweat glands, which is 10 times more than chimpanzees. This abundance of sweat glands combined with reduced fur created a highly effective cooling system, which was key to surviving in the hot, open savanna environments. Now, this sounds like a solid theory, but like with all of science, this wasn't the only theory proposed. Before the thermoregulation hypothesis gained widespread acceptance, several early theories attempted to explain why humans lost their thick fur. While these theories provided some intriguing possibilities, they ultimately lacked sufficient evidence or clashed with established facts about human evolution. One of the most popular theories, the aquatic ape theory, proposed that human ancestors underwent an aquatic phase, living in environments like shorelines and swamps. It might seem funny today, but proponents suggested that fur loss, similar to what is observed in aquatic mammals like whales and dolphins, would have made humans more streamlined in the water. They also argued that bipedalism could have developed from wading in shallow waters. However, this theory was widely dismissed by the scientific community due to lack of fossil evidence supporting a prolonged aquatic phase in human evolution. Other early theories focused on social factors rather than environmental pressures. One such theory suggested that humans lost their fur to visually distinguish themselves from other primates. However, this idea lacked compelling evidence and is considered implausible. Another theory combined hygiene and sexual selection, proposing that hairlessness helped reduce the number of parasites like lice and ticks, making individuals appear healthier and more attractive to mates. While it's plausible that hairlessness could have helped reduce parasites, this theory doesn't explain why other primates in similar environments who also suffered from parasites retained their fur. These early theories fall short for a few key reasons. Many of them lack solid support from fossil records, genetic studies, or comparative anatomy. For instance, the aquatic ape theory still has no fossil evidence to back up the idea of a significant aquatic phase in human history. Other theories oversimplify the complex factors that shaped human evolution, often focusing on just one factor, while ignoring the interplay of environmental, biological, and cultural forces. Some also contradict established knowledge about primate evolution and the conditions that prevailed along critical stages of human development. The current understanding of human hair loss is much more comprehensive, acknowledging the complexity of our evolution. The thermoregulation hypothesis, supported by fossil evidence, genetics, and comparative anatomy, is now considered the most plausible explanation. With all that said, would you be surprised to know that technology played a serious role in us losing our fur? See, in addition to biological and environmental pressures, the early technological advances of fire and clothing played a surprisingly important role in the story of human hair loss. It is probably clear that these innovations didn't directly cause us to lose our thick coats, but they allowed our ancestors to stay warm and protected without it, setting the stage for even further reductions in fur without risking survival. It all started around 2 million years ago when early humans learned to control fire. This discovery was monumental, not just for cooking or light, but for warmth too. That's because fire allowed our ancestors to huddle close and stay warm through chilly nights and in colder climates where thick fur was once essential. And beyond just warmth, fire served as a defense, warding off predators. And since fire provided security, our ancestors no longer relied as heavily on fur to shield them from the cold or lurking threats. Over generations, early humans with less fur could still survive comfortably, making it more likely that hairlessness would spread. The next milestone in this journey was the advent of clothing, around 170,000 years ago. With animal hides and other materials, early humans could protect themselves from the cold in a new way. Clothing gave them insulation that fur once provided, creating a whole new option for warmth and shielding their skin from the sun, wind, and rain. As clothing became more common, there was even less need for fur, allowing this trend toward hairlessness to continue. So with that said, what can we say about hair today? Despite our reputation as the naked ape, humans haven't lost all body hair. We still have patches on the head, armpits, and pubic regions. This selective retention is rooted in a mix of evolutionary utility, biological function, and social signaling. So what's the purpose of head hair? One area that retained dense hair is the scalp, and this hair plays a key protective role. Our thick head hair acts as a natural shield against the sun's UV rays, safeguarding the sensitive scalp from burns and reducing the risk of overheating. This was essential for early humans who adapted to the African savanna, where shade was limited. In addition to sun protection, head hair also regulates temperature, trapping heat in cold weather and insulating against direct sun in warm weather. Moving from biology, head hair has also evolved as a social signal, with hairstyles used throughout history to indicate status, age, and cultural affiliation. In societies worldwide, hair has become a medium of personal expression and social differentiation, reinforcing its role beyond simple biological function. Okay, what of armpit and pubic hair? The hair in the armpits and pubic regions, though less discussed, serves distinct purposes. In the armpits, hair growth coincides with the concentration of apocrine glands, which produce an oilier sweat tied to body odor. This odor, though subtle in modern humans, may still serve as a cue in social interactions, conveying individual scent markers that potentially communicate genetic compatibility and health. In the pubic area, hair functions similarly by trapping pheromones released by apocrine glands, aiding in social and potentially sexual communication. Additionally, pubic hair reduces friction, which protects sensitive skin during physical activity and serves as a barrier that can help guard against bacterial transmission. But that wasn't all, because our hair may have been affected by sexual selection's influence. Charles Darwin posited that human hair patterns might be shaped by sexual selection, where mates were chosen based on a preference for less body hair. While this may have refined certain features, it is now seen as a secondary factor to thermoregulation, the dominant theory behind human hair loss. Today, sexual selection likely reinforced the distribution of hair in specific areas, shaping attributes like facial and head hair for signaling, as well as scent-orientated hair in the armpits and pubic region. But what do you think about the mysterious journey from fur-covered ancestors to the smooth-skinned humans of today? Does the story of how we shed our fur fascinate you, or do you think we're still scratching the surface? We'd love to hear your thoughts. Drop a comment below and let's talk evolution. Until next time, stay curious, stay questioning, and remember, our evolution is a story that is still unfolding.